Hi everyone. In this section I am going to be discuss about the 01 knapsack by using branch and bound. So in my earlier video or introduction part of the branch and bound, I discussed we have the three searching strategies: FIFO, LIFO and least cost. So now I am going to be use the least cost approach to solve the 01 knapsack problem. Already I told you. So out of those three, based on our problem statement, we are going to be choose our searching approach. So now I am going to be use least cost approach. So first of all, I want to recall what is the 01 knapsack problem. So the 01 knapsack problem is we have n number of items. Each item has its own profit and weight. And we have one knapsack, nothing but a bag. When we have a bag or a knapsack, it having certain capacity. That capacity we call as knapsack capacity, labeled as M. Our problem statement is, our problem aim is to get the maximum profit which items you are going to place into the knapsack. Here the condition is, if you want to place all the items into the knapsack, not possible. That is nothing but summation of all items weight is greater than our knapsack capacity. So to solve this one by using branch and bound, particularly least cost method, we are following the strategy of, for each and every node we are going to be calculate two values. One is the upper number, second one is the lower number. So upper number we called as the lower bound and the lower number we called as the upper bound. Sir, why we called upper number is the lower bound and lower number is the upper bound? Already I discussed in the branch and bound introduction part, it is going to be solve only the minimization problems. But what about the knapsack? Knapsack is optimization, particularly maximization, not a minimization. How you are going to be achieve the maximization with the help of minimization? To change the signs. Good. When you are going to be change the signs, then that we called minimization problem. When we change the sign, nothing but the lower becomes the upper and upper becomes the lower. So that's why we are going to be change its label. Apart that, nothing is there. So I hope you understand as of now. Now I am going to be consider one example to solve 01 knapsack by using branch and bound approach. I have 4 items and I have the knapsack capacity 15. It may be labeled as CRM, and I have some profits. Profits also sometimes called as values. What is the profit I have? I am going to be write 10, weight is 2, 10, weight is 4, 12, weight is 6, and 18, weight is 9. So that is the given. We must be change the given order items into one order. The order is PI by WI, nothing but the profit weight ratio of ith item must be greater than or equal to the next item, nothing but profit of I plus 1 by weight of I plus 1. Sir, why we are going to be arrange this one? What is the need for us? If you arrange this one, then only going to be set the boundary is easy for us. Otherwise, setting boundary is very difficult. So to avoid it, we are going to be use this one. Here some of the members may be going to be think, sir, what is the time we are going to be spent to sort these are all? Maybe the in login. But our problem is the NP hard. nothing but exponential. So n log n is not a time or a big time compared to the exponential. So that's why first I am going to arrange all the items within this order. Now what is a 10 by 2? 5. What is 10 by 4? 2.5. 12 by 6? 2. 18 by 9? 2. Yes, I have the same order, so no need to be change it. If it is not, we must be change it. So first I am going to be create one node. That node is 1. For this node I am going to be find the two numbers, lower number, lower bound as well as upper bound. So the upper bound having fractional also. So what is that meaning? So observe, what is the first item weight? 2. What is our knapsack capacity? So initially our knapsack capacity is 15. What is the first item weight? 2. 15 minus 2. What is the remaining free space in the knapsack? 13. So what is, as of now, what is the profit we are getting? First item profit 10 plus 13. What is our second item weight? 4. So 13 minus 4. What is the remaining free space? 9. What is the profit you are getting after adding the second item in knapsack? Second item profit also along with previous profit. Now free space is 9. What is the third item weight? 6. So what is our free space? 3. Nothing but I have added third item also. What is the profit as of now? Previous profit plus third item profit. What is third item profit? 12. First I am going to be find the lower number. Lower number is nothing but the upper bound. So what is the free space in knapsack? 3. But what is the fourth item weight? 9. Is it possible to place 9 cages with a 3 cages space? No, not possible. So that's why for the lower number I am going to be consider the fraction also. Even though our 01 knapsack does not allow the fractional, for our bounding setting I must be consider the fraction also for the lower number. Lower number nothing but upper bound. So 3 cages, nothing but how 3 cages I am going to be considered, the free space is 0. Then what is the profit I am getting? So for the 9 cages 18. For 3 cages I have only, that is nothing but 3 into 18 by 9. In other words 18 by 9 into 3. So nothing but 6. So nothing but we are getting the profit as 6. What is the total profit as of now? 10 plus 10 20, 20 plus 12 32, 32 plus 6 38. So that is our upper bound. What is the sign? Negative. Don't forget it. Now come to the upper number, nothing but the lower bound. The lower bound we did not include the fractional. Before fractional what is the value we have? Before fractional nothing but up to this. What is the profit we are getting? This one only. So this is a fractional. So 10 plus 10 20, 20 plus 12 32. So that is our lower bound. Initially we are going to be maintain one global variable, that is upper initially as infinity. Upper initially as infinity. Now what is the problem we have? 01 knapsack. So that is nothing but which bound does not allow the fraction? Lower bound. So now we compare this lower bound or upper number with this upper label. If upper, nothing but better to fix the labels L and U and upper. If L is less than upper, then update the upper. So what is our L value? Minus 32. What is our upper value? Infinity. Minus 32 is less than infinity. Yes. Now we will update the upper. What is the upper now? Minus 32. So now which node having the least upper, we are going to be considered that first. So one node itself, which is the minimum. Now I am going to be consider this. So what is that meaning? I am going to be consider my left side is first item in the knapsack, right side is first item not in the knapsack. When the first item in the knapsack, that is the second state, not in the knapsack, that is the third state. Now observe, when the first item in the knapsack, so then what is the L value? No change without fraction. What is the U value? With fraction? No change. Now come to the node 3. What about my L value without fraction? Nothing but first item not including. When the first item not including, so then I want to change, I want to calculate my values once again. My free knapsack is 15. What is the first item not going to be considered? We are going to be considering from second item onwards. So when we are going to be considered from the second item onwards, what is the second item? Weight 4. So 15 minus 4. Free space is 11. What is the profit? Second item weight. Profit, sorry, 10. Now free space is 11. What is the third item weight? 6. 11 minus 6, 5. What is the third item profit? 12. What about the fourth item weight? Free space is 5 and 9, but unable to place. That is without fractional. Without fractional, what is the value we are getting? 10 plus 12? 22. So minus 22. U value is nothing but with fraction. So what is the free space? 5. So 5 minus 5 only. Nothing but 8 by 9 is the 2. 5 into 2, 10. 10 plus 22, 32. So that is minus 32. So once you have this one, you must be think two conditions. Here U is greater than upper, kill it. Here what is the U? Minus 38. Here what is our upper? Minus 32. Minus 38 is greater than minus 32? No, my dear, observe the minus sign. Now observe this one. What is our U? Minus 32. What is our upper? Minus 32. Minus 32 is greater than minus 32? No, equal. If it is upper, then only kill it. Then observe the second condition. What is the second condition? Minus 32 is less than the upper? No, minus 32 is equal to the minus 30. Minus 22 is less than the minus 32? No, minus 22 is larger than the minus 32. Observe the minus sign. So no need to be update. Now, which node we are going to be expanded now? So which method we are following? LC, nothing but the least cost. The least cost, observe the upper bound value. What is the here upper bound value? Minus 38. Here what is the upper bound value? Minus 32. Which is minimum? Minus 38. Now I am going to expand this one. When I am going to expand this one, this node is 4 and this node is 5. What is this meaning? X2 equal to 1. Right side x2 equal to 0. Now observe. In this path, you consider the first item and second item. L value and U value does not change. Because from the first onwards, we consider all the items. Here also 1 and 2 consider. Now come to this right side. What is that meaning? We consider item 1 and we doesn't consider item 2. Nothing but we want to find the calculation once again. Now I am going to be find the calculations. So 1 consider. Now 2 not consider. That is nothing but I am not going to be consider the second item. So my initial capacity is 15. First item place. Free space is 13. Profit is 10 as of now. 13 minus. Second item not considering. Third item. 6. 12 plus. What about the 13 minus 6? 7. So fourth item fully 8 possible? No. So the L value is minus 22. What about the fractional part? So 8 by 9 is the 2. What is our free space? 7. 7 into 2, 14. 14 plus 32 22 36. Yes, upper bound is minus 36. Now once again check the possibilities. What is our u? You are generating this one. Which node you generated? You must have checked these two conditions. U is greater than upper, minus 36 is greater than minus 32. Now what about our u? Minus 36. Minus 36 is greater than minus 32? No. And what about second condition? Minus 22 is less than minus 32? No. So this is also lie. Now which node we are going to be expand? 3, 4, 5. Which node having the least cost? So minus 38, minus 36, minus 38. The minimum is minus 38. So we are going to be consider this node. What is this meaning? x3 equal to 1 and x3 equal to 0. So x3 equal to 1, there is no change within that. I am going to be give the in order. So 6 and 7. So L value not change, minus 32 without fraction, and U with the fraction minus 38. Now come to this side, right side. What is that meaning? 1, 2 consider, 3 not considering. So I am going to be find once again without third item. Without third item, I am going to be find for the L value nothing but without fraction. So initially it having the 15 knapsack capacity, 15 minus first item 2. What is that meaning? Remaining free space is 13. For your profit 10 place. 13 minus what is the second item weight? 4. Free space is 11. What is second item profit? 10 place. What about third item? Third item we never consider in this case because x11, x21, x3 is 0. Solution vector indicates 1, 2 only consider, 3 ignored as of now. So that means unable to maintain this item. Sorry, 13 minus 4, 9, not the 11. Please update it. And what about our fourth item? 9 minus 9. Full item we consider 0. What is the profit we are getting? 18. What is the total weight? Total weight 15. There is no free space. Total profit is 18. So without fraction. So that is our L. What about with the fraction? There is no free space in the knapsack. So that is also the same. What is that with fraction? That is our U minus 38. Now once again you want to check two conditions. U must be compared U with the upper and also L with the upper. What is our U? Minus 38. So minus 38 is greater than upper? No. What about our L? Minus 38 is less than upper. Minus 38 is less than minus 32. Yes. Now we want to update the upper. So minus 38 is less than minus 32. So that's why we are going to be update this one minus 38. So when you are updating as minus 38, you want to check when upper is update, you want to check all other live nodes. Now you go with a live node 3. What is the kill possibility? U minus 32 is greater than minus 38. Check it. Minus 32 is greater than minus 38. Yes, you want to kill this. Then go for the 5. Minus 36 is greater than minus 38. Minus 36 is greater than minus 38. Yes, you want to kill this. Then what about this one? Minus 38 not greater than, minus 38 also not greater than. Is it clear as of now? Yes. Now which item I am going to be considered, nothing but which state I want to expand next. So based on our LC, which node have the minimum cost, u is minus 38, here u also minus 38. So I am going to be expand my C, nothing but the 6. Eight, 9 in order. What is that meaning? X4 equal to 1 and X4 equal to 0. If it is X4 equal to 1, is it possible to consider the fourth item also fully? No. So this is not possible, because the lower bound, nothing but the L value. What is the L value? Without fraction. Without fraction, what we are getting? 32. So 32 indicates the first 3 items profit only. 10, 10, 12. Fourth item is unable to place. Fourth item is unable to place. So that's why I am going to be kill it. Now come to this one. What about this one? L value does not change. Minus 32. And what about my upper? Nothing but 1, 2, 3 consider. Fourth not consider. When not considering a fourth item, then what is it value? 10, 10, 12. 32 only. Upper also minus 32. Now observe which node I want to be expand. 8 is kill, 5 kill, 3 kill, nothing but 7 and 9. Which is the minimum cost? 38. So now I want to expand 7. So now I am going to be expand with a 7. So the 7, when I am going to expand it, so like this one. So x4 equal to 1 and x4 equal to 0. If it is equal to 1, 10. If it is equal to 0, like 11. What is the meaning of this one? I consider 1, 2, 3 not consider, and 4 I am going to be consider. So what is the L value? Already we calculated that case. 1 consider, 2 consider, and 4 consider, 3 ignored. So that means what is the L value we are getting? Minus 38, and U also minus 38. Come to the 11. What is that meaning? 1 consider, 2 consider, 3 not consider, 4 also not consider, nothing but 3 and 4 not consider. So then what is our L value? 10 and 10 only 20. What about our U value? Minus 20. Now check it. So 10th node, U minus 38 is greater than minus 38? No. Minus 38 is less than minus 38? No. Come to this one. Minus 20 is greater than minus 38? Yes, you kill it. And 9 also you want to check. We forgot that earlier. What is our U value? Minus 32. What is our upper value? Minus 38. Minus 32 is greater than upper? Yes, we kill it. Nothing but only 1. We have verified all the possibilities. What is the maximum profit we are getting? That will be the upper number. What is that? Minus 38. So this is the maximization problem. We converted the sign. So that's why what is the maximum profit it gives us? The maximum profit is 38. What is the solution vector? Observe that path. I am going to write the solution vector. Vector size is the number of objects or the items. x1 1, x2 1, x3 0, x4 1. Now check it. What is the profits? 10, 10, 12, 18. What is the weights? 2, 4, 6, 9. Weights are 2, 4, 6, 9. That means third item not included in our knapsack. What is the total profit it gives us? 10 plus 10 plus 18, 38. Yes. What is a knapsack? 2 plus 4, 6 plus 9, 15. Our knapsack capacity is 15. We are getting as the profit as 38. So with the bounding function, we try to reduce the time. So how we set the bounding function? With the help of LC approach, nothing but the least cost approach. Then what is the algorithm's time complexity for this one? Observe the state space tree. So that is also exponential, nothing but order of 2 power n into some n square like. So ignore about this one, still it is an exponential. So this is about the 0-1 knapsack using branch and bound, particularly by using least cost approach or least cost strategy. So thank you all.